A farmer is building a fence around a horse arena. He knows the size of the arena. He needs 3 rows of fencing. And every board is only 8½ feet long. He ordered 130 boards. Enough or not enough? This is a multi-step problem because one calculation is not enough. We have to find the distance around the arena, then the wood for 3 rows, then how many boards that takes. Let's figure it out together. When a word problem has more than one step, use this strategy. First, understand. What is the problem actually asking? Second, identify. What information do we already know? Third, plan. Which operations do we need, and in what order? Fourth, solve. Calculate carefully. Fifth, interpret. What does the answer actually mean in the real world? And sixth, check. Is the result reasonable, and are the units correct? Drawing a diagram can make a complicated problem much easier to understand. Here is the horse arena. It measures 120½ feet by 66¼ feet. Perimeter is the distance around the outside. Watch us trace once around the whole arena. Opposite sides are equal, so we add 2 lengths and 2 widths. 2 times 120, and 1/2 is 241. 2 times 66¼ is 132½ Add those together. 241 plus 132½ equals 373½ feet. That is 1 trip around the arena. 1 trip around the arena is 373½ feet. But this fence has 3 horizontal rows, so we need 3 times that amount of wood. Here is the first rail. Now a second rail, and a third. 3 times 373 and 1/2 equals 1,120½ feet. That is the total length of fencing. Now convert that total length into boards. How many 8½ foot planks fit into 1,120½ feet? That is 1,120½ divided by 8½ Convert the mixed numbers. 1,120½ is 2,241/2. 8½ is 17/2. Divide 2,241/2 divided by 17/2. Flip the second fraction and multiply. The 2's cancel. 2,241/17. That equals 131 14/17. Can a farmer buy 131 14/17 of a plank? No. Every part of the fence must be built, so we round up to 132 whole planks. He ordered 130. That is not enough. He is short by 2 planks. Here is the important lesson. A calculator result is not always the final answer. 131 14/17 is the exact calculation. But the farmer needs whole planks, so that number becomes 132. We round up because a leftover piece of fence still needs a whole board. The situation tells us what to do. If you had $131.8, you would not automatically call it $132. Rounding depends on what the number represents. Let's try a decimal problem. A marathon is 26.2 miles long. Water stations are placed every 2.62 miles, and there is also one at the starting line. How many water stations are needed? 26.2 divided by 2.6, 2 equals 10. Does 10 mean 10 stations? Watch. Those 10 equal spaces are gaps. 10 gaps need 11 points. Station 1 at 0 miles. Station 2 at 2.62 miles. Keep going until Station 11 at 26.2 miles. 10 plus 1 equals 11 stations. 10 gaps do not mean 10 stations. 10 gaps mean 11 stations. Same marathon. There are 5 medic tents, equally spaced, including one at the start and one at the finish. How many equal gaps are there? 5 tents make 4 spaces between them. 26.2 divided by 4 equals 6.55 miles. place the tenths. 0 miles, 6.55, 13.1, 19.65, and 26.2. With 5 points, there are 4 equal spaces. Same idea as the water stations, just flipped around. To solve problems like these, we also need to be fluent with fractions. We add, we subtract, we multiply, we divide, and we simplify. Let's review each skill, one at a time. Start with 8/12. Here is a bar with 12 equal pieces, and 8 of them are shaded. Both 8 and 12 can be divided by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So 8/12 equals 2/3. The pieces get bigger, but the amount shaded stays the same. You simplify a fraction by dividing the numerator and the denominator by the same non-zero number. The value does not change. Now 48/18. First divide both by 2. 24/9. Are we finished? Not yet. 24 and 9 still share a factor of 3. 24 divided by 3 is 8. 9 divided by 3 is 3. So we get 8/3. 8/3 is simplified completely. A fraction is in simplest form when the numerator and denominator have no common factor greater than 1. Don't stop halfway. Adding with the same denominator. 4/6 plus 1/6. The pieces are already the same size, so we are just counting sixths. Add the numerators. 4 plus 1 is 5. Keep the denominator. 5/6. Do not add the denominators. 4/6 plus 1/6 is not 5/12. That would make the pieces the wrong size. Add the numerators. Keep the denominator. Subtracting works the same way. 4/9 minus 3/9. Start with 4 shaded ninths. Remove 3. 1/9 is left. Same size pieces, so the denominator stays 9. 4 minus 3 over 9 equals 1/9. Different denominators are trickier. 4/6 minus 1/4. Look, sixths and fourths are different sizes. We cannot subtract them yet, because the pieces are not the same size. Find the least common denominator. Multiples of 6, 6, 12, 18. Multiples of 4, 4, 8, 12. The first shared multiple is 12. Convert. 4/6 equals 8/12. 1/4 equals 3/12. Now the pieces match. 8/12 minus 3/12 equals 5/12. Remember the steps. Find the LCD, make equivalent fractions, add or subtract the numerators, keep the common denominator, and simplify if you need to. Multiplying fractions. 4/7 times 3/5. Here is an area model. 7 vertical sections. 5 horizontal sections. Shade 4/7 one way. Shade 3/5 the other way. The overlap is the product. Count. 12 overlapping pieces out of 35. When multiplying fractions, multiply numerator by numerator and denominator by denominator. 4 times 3 is 12. 7 times 5 is 35. 12/35. You can cross-simplify before you multiply. 7/12 times 18/35. 18 and 12 share a factor of 6. 18 divided by 6 is 3. 12 divided by 6 is 2. 7 and 35 share a factor of 7. 7 divided by 7 is 1. 35 divided by 7 is 5. Now we have 1/2 times 3/5, which is 3/10. Cross-simplifying keeps the numbers smaller, but it does not change the answer. Dividing fractions. 4/7 divided by 3/5. Remember the phrase, keep, change, flip. Keep the first fraction, 4/7. Change division to multiplication. Flip the second fraction. 3/5 becomes 5/3. Now multiply. 4 times 5 is 20. 7 times 3 is 21. 20/21. So 4/7 divided by 3/5 equals 20/21. Keep, change, flip is not a magic trick. Here is why the flip works. How many 1/2s fit into one hole? Split one hole into halves. 2 halves fit. So 1 divided by 1/2 equals 2. Dividing by 1/2 has the same effect as multiplying by 2, and 2 is the reciprocal of 1/2. Same idea with 4/7 divided by 3/5. Multiplying by the reciprocal, 5/3, performs that same division. Quick challenge. A recipe uses 3/4 cup of flour per batch. You have 3 cups of flour. How many full batches can you make? That is 3 divided by 3/4. Write 3 as 3 over 1. Keep, change, flip. 3 over 1 times 4/3. The 3's cancel. 4. You can make 4 full batches. Before you calculate, decide which operation you need. Problem A. You walked 2 3/4 miles in the morning and 1 1/2 miles in the afternoon. That's adding. Problem B. You have 5 1/2 feet of ribbon, and each piece needs to be 1/2 foot. How many pieces? That's dividing. Problem C. You need 3/4 of 2/5 of a container. Of means multiply. Here's your cheat sheet. For multi-step problems, understand, plan, solve, interpret, and check. Simplify by dividing the numerator and denominator by the same common factor. Same denominator? Add or subtract the numerators and keep the denominator. Different denominators? Find the LCD, make equivalent fractions, then calculate. Multiply. Top times top, bottom times bottom. Divide. Keep, change, flip, then multiply. Always check the units and ask whether the answer makes sense. Fraction rules help us calculate. But great problem solvers do more than calculate. They figure out what the numbers mean. Understand it, solve it, check it,